Hi. This research work is regarding of a hardware schemes for smart indoor robotics to prevent backcrash framework using FPGA based multi robots. We authors want to explain you regarding of this particular one, right? Yes, when we look into the thing here, this is regarding of the flow chart. What is our ideation behind this? The first one, when we are having of a robots in a parking, the multiple robots, we have seen a lot of robots was come entering up to the point of the entering into the parking spaces only. When the problem statement is when robots will comes out from the parking space, what are the challenges we are going to observe? The most challenge is we are calling as a the collisions are going to happen over. So we require a backcrash technology also to avoid these scenarios. These scenarios are going to happen in a different versatile parking spaces like perpendicular parking, and when the parking was in with a different type of a inclination methods, all these scenarios. So this was a idea problem statement we are providing of a solution for this. So the start robot, when the all the what are the sensors which we are having on robot are going to have this particular sensing of the information, so that we are calling as a sensor vision. Then afterwards it goes towards the where exactly the robot was positioned over. Either it is a localized in a particular parking or inclination parking, that justification is did. And again, the scenario it will evaluate by using of the techniques we are having, which we mentioned internally as a by the velocity modulation analysis, so that we can identify whether it's a in a static mode or a dynamic mode. When it's a static mode, right, fine, then it moves towards the like a round robin schedule. Means what was the purpose of the round robin schedule algorithm? Here we are having of a four robots are there, which robot have to come out from the exit from the parking space, so that one robot will we considered here the one robot as we are having of robots as a R1, R2, R3, R4. Among that, R2 robot is considered as the leader robot. The leader robot will assign the scheduling to the each of the robot with respect of the exit from the parking. At that time, they're evaluating of the behavioral control, and after that, they confines once again that yes, their job is completed. Again, the round robin procedure based on that, our robots will come out and we are safely come execute this particular one. So for this execution, we came out with a novel approach that we're calling as a hardware schemes for the backcrash prevention. So how to do all these things? We are having of a integrated with a Wi-Fi model and digital compass and ultrasonic sensors and all these things. And partial reconfiguration technique is our novel approach. Right. Among these, we are going to use the when the partial reconfiguration when we interface with the static module and the dynamic. Here in this case, we are going to discuss regarding of the static model. The static model we shared as a round robin task assignment system we are having. And among that, we are having of it two things as a perpendicular parking and inclination parking. The same was executed and results were represented here as a starting of the results. The experiment validation is did, and it's a respective device utilization are also mentioned over in this particular one. Let me see the next scenario. Right here, we are going to have the experimentational thing here. So yes, now we are having of our thing here, right? The robots are coming out. Fine. If we observe the robot, the robots again is classified into models as a R1 and R2 and R3 and R4 models. So that, right, the R1 robot, which is here, we are calling as a odd number of odd robots. The R1 robot is out, and at same R3 robot is out, and R4 is looking after once the R3 is left the path, and then R4 is comes to scenario and looks into its environment, and R4 is also moving. Now, once the R4 is left over, next the here the robot is there. That robot we're calling as a R1 robot that will comes once the R4 is exited from the on the way. So now R1 is came out, right? Once the R1 is robot is came out, then archer robot, which we are called just now as the leader robot. The leader robot will comes into a scenario out and that executed. So how this happen, Bhavan? By using of a round robin scheduling algorithm for avoiding of the collision among the robots in a static environment. So this is about the static environment and things. Yeah, thank you.